You're making a square frame of uniform width for a square picture that has side lengths of 2 feet. The total area of the frame is 5 square feet. What is the length of the sides of the frame? So let's take just a moment to label this picture. What we're first going to notice is that it's a square. And remember, when we have a square, the sides are always equal in length. It is telling us that according to the wording in this problem, the picture itself has a side length of 2 feet. So if our picture is usually, this pretty part in here, we can go ahead and say that in here is, that length there would be 2 feet. And then since this is a square, that height is also 2 feet. It tells us that the total area of the frame itself is 5 square feet. When I look at the area of the frame, I'm thinking about the material I would use to build the frame. And they're telling me I have 5 square feet of material with which to build this frame. Ultimately, they're asking us, what is the lengths of the sides of the frame. So what I don't know, you can see it there, is the length of the sides of the frame. So if we're declaring our variable, we could say x is the length of the side of the frame. And this will be in feet. So here's an x, which means here also is an x. If I want to figure out the total, before I go ahead and think about that, let's go ahead and get a verbal model, shall we? What I'm going to go ahead and notice is that if the total area of the frame is made of 2 pieces, we could say that the area of the frame itself can be found by taking the area of the picture and the frame and just subtracting the area of the picture itself. It's kind of like we're punching a hole in the whole area to just get the area of the frame. So that area of the frame, you might recall, was given to us in the problem. The area of the frame itself was 5 square feet. So that's just that building material right in there. The area of the picture and the area of the frame would be described by just taking this whole length times this whole width, or x times x, which is x squared. And then, of course, I'd have to just subtract, or cut out, rather, the, area of the picture inside. So that's 2 by 2, which gives us 4 square feet. So if I just want to know, sort of the lengths of the sides of the frame, I can use this equation to help me go ahead and do that. What's interesting is that there's 2 ways to solve this equation. One, we could set one side equal to 0 and then factor and solve. The other way to do the problem would be to just sad map. So instead of showing you a graphing approach to check, I'm just going to show you 2 different ways to solve the problem. So the first way would be sad map, or solving by undoing. And in this case, we would need to take our equation and add 4 to both sides. So we get 9 equals x squared, and then to get that x value all by itself, I just square root both sides. So x equals plus or minus 3. The other way is to solve by factoring. In this case, I would have to go ahead and take a second to get one side equal to 0. So if I subtracted 5 from both sides, I get 0 equals x squared minus 9. This is what we defined earlier in the chapter as a difference of 2 perfect squares, so I use the square root method for factoring. The square root of x squared is x. The square root of 9 is 3. And then we put a plus and a minus in between. If I use the zero product property, I set x plus 3 equal to 0, which would give me a value of negative 3. And then I'd have to set x minus 3 equal to 0, adding 3 to both sides. I get positive 3. So what's interesting here is that you could see, regardless of how I solved for x, I did get the same answer. Now, we would never have a picture frame that has negative sides, so we could rule out our negative response and just say the length of each side is 3 feet. The length of each side is 3 feet. That's your sentence there.